CSEC Mathematics, May 2025. Now we are at question 10. Vectors and matrices. Alright. So, let's see what is going on here. In the diagram below, OPQL is a parallelogram. So we have OPQL, alright. OP is R, OL is S, T is the point such that PQ is equal to QT. Okay, so PQT is a straight line that, and then from P, distance from P to Q is the same distance from Q to T. Okay. The point M divides PL into the ratio 2 to 1. That means from M to L, so from P to M is twice from M to L. Alright. They say find in terms of R and S, PL. Alright. What do we see? Let us just copy the parts of the diagram that we're going to need and paste it over here. And let's see now. Find in terms of R and S. PL. Alright, so let's paste it over here. I'm going to find PL in terms of R and S. Let's see how we're going to do that. Alright, so here now we have PL. Now remember, you have to remember your triangle law when it comes to your vectors. Alright? Have to remember that. Now, here you're going from one place to another. The question is there an alternate route that you can take along the diagram? Are there other paths you can take? Alright? Now, the path that you could take without going any longer distance, the direct path you should take is going to be the resultant of your vector. And the other path that you could take are other vectors that you add up to get that resultant. Alright? So let's see something here. PL. You're going from P to L. Now, that's one thing you can think about it. Could be force vector, right? Or it could be other vectors, but let us consider it as displacement. Remember, displacement is the distance in a specified direction. That's a vector. So you're going from P to L. Now, what if this road is blocked? Well, one way you could reach L from P is to go to O, bend the corner, and go to L, alright? So you can say PL is equal to PO plus OL. See that? So PL, the vector PL is equal to vector PO plus vector OL. Alright. But the thing now is this. If you're going from P to O, is a negative of OP. I remember what the question says. OP is equal to R. Alright? So, here now, we're going to look at the R a little later. But remember, you must find it in terms of R and S, you know. This is going to be negative OP. So PO is a negative, the inverse vector of OP plus OL. But remember, OP is R. Alright? So what you say here is that is negative R. Let me just write uppercase R. Alright? It's lower, really, let me see if I can write lowercase properly. Alright, say that is my lowercase r. Plus, what is OL? OL is S. Write the S so that it doesn't look like 5. So therefore, PL is equal to negative R plus S. See that? Alright. So that is part A. 1 mark for that. Part B now. 2 marks. OM. Let me just copy this and paste it over here. We're going to find OM now in terms of R and S. Now, OM would be along here. Alright? Let us draw a line representing OM. This is OM. Let's draw 2 arrows as a resultant. Now, we're going along OM. Well, certainly, what you could do, instead of going straight from O to M, you could go O to P and then P to M. Right? So the vector OM is equal to the vector OP plus the vector PM. So vector OM equal vector OP plus vector PM. Alright? OM is OP plus PM. See that? Because with this, you know, we draw an arrow like that to show that you're going from P to M. Alright, now OP is R. So we already have that part. So OM is R plus PM. Alright, now PM. Now the thing is, if you look at PM, it's part of PL, right? It's part of PL. You already have PL, so you know what PL is. But how much? Now remember, the question says here, M divides PL in the ratio 2 to 1. So if you could cut PM like this, what you would say is that from P to L is divided into three parts. 1, 2, which is from P to M, and then 1 from M to L. So here, what you have is the 2 from here to here, and the 1 from here to here. See that? Now, thing is, PM is 2. The distance along PM is 2. That's the magnitude of PM. But the magnitude of ML. And remember, the two lines, vertical lines, mean the magnitude of a vector, right? The magnitude of from M to L is 1. So therefore, what's the magnitude of P to L? Well, 2 plus 1, which is 3. So therefore, from P to M, PM compared to PL is 2 to 3. Alright? So to go from here to here is 1, 2 from P to M. But to go from P to L is 1, 2, 3. So it's 2/3. Alright? So what you can say is that PM is 2/3 PL. So I can say this is R plus 2/3 PL. See that? Now PL is negative R plus S. Alright? So is equal to R plus 2/3 negative R plus S. So that's what we have there. Now let's open the bracket and simplify and so on and so forth and see what's going to happen. This is equal to R plus, well, it's going to be a minus when you open the bracket, minus 2/3 R plus 2/3 S. Alright? Now, this is 1R minus 2/3 R. But to make common denominators, we could say 3/3 R. 3/3 is the same as 1, you know. So you have 3/3 and you minus 2/3. How many thirds you have left? 1/3. So it's 1/3 R plus 2/3 S. Well, you could factor out the 1/3 and say this is R plus 2S then. Alright? So you see that? Alright, so that's part B of that. Now, okay. This part says prove that the points OML are collinear. Alright, so collinear means that OMT, prove that the points OM and T are collinear. When you have points that are collinear, it means if you move from one to the other along all of the points, you move from one end to the next end, passing through all the points, you're traveling on a straight line. There's no bend. Alright? They are collinear. Let me just copy and paste this thing over here. Alright. Now the thing is, all of this working, I'm I'm going to need a space, and I don't want to run out of scrolling space either, so I'm going to just write the answer up here. So it's negative 1/3 r plus 2s. That's negative 1/3 r plus 2s. Okay, let me just erase these parts down here now. All right, so there we have that, OM. Now, it said to prove that OM and T are collinear. That means if you draw a straight line from O to T, it would pass through M as well. Let me see something here. Okay, you're going to prove that OM and T are collinear. By the way, let me just erase these other work that we did from before. I don't want to crowd the screen too much. Alright, you must prove that O, M, and T are collinear. Alright, now, if you have 2 points, what you can do, or 3 points, I mean, it's 3 points, not 2. Find the vector OM. Then find the vector MT. And they should have the same direction. That means if one of them, if one of these vectors is, say, r plus s, the other one can be 2 r plus s, or it could be 3 r plus s, or whatever. The only difference would be the magnitude. Now, if you have a vector r plus s and another one 2 r plus 2s, or 3 r plus 2s or so, these are not collinear, right? Because guess what? If you go r to the right and s up, and you go 2r to the right and 2s up, these would be collinear, right? Straight line. But you cannot go r to the right and s up, and then you go 2r to the right and s alone up, because you would not have these lines coincide. You must move up so that the lines coincide. Alright, so let's see what's going to happen in this case. What is the vector OM? Did we do it already? Oh yeah, we have the vector OM already. Right? Now, by the way, let me see something here. Did I make a mistake earlier? PLOM, negative 1/3 r plus 2s from O to M is r plus 2/3. Let me just look back at this. R plus 2/3 PL, but PL was negative r plus s. Alright, so it's 1r 3/3 minus, I'm wondering why I have a minus in front of this, minus 2/3 r plus 2/3 s. But 3/3 minus 2/3 is 1/3. Is 1/3 r plus 2/3 s. So if we factor out the 1/3, we get R plus 2S. Right, there shouldn't be a minus sign in front of this. Where did I get this minus sign from? My. Right, there shouldn't be any minus sign there. Alright? Because if you're going, R would be moving horizontally to the right. And PM would be moving horizontally. The horizontal component would be to the right. So OM should be positive. There should be no negative R. But anyway, alright. So we corrected that. Now, the thing is, we know OM already. What we need to do is to find MT and compare it with OM. Alright? So how are we going to find MT now? Let us see. If we're going from M to T, what I could say is that MT, the vector MT, instead of going directly from M to T, we could go this way to P, bend the corner, and then to T. So MT is equal to MP plus PT. Alright, let's write that down below here. MT is MP plus PT. So MT equals MP plus PT. Alright, MT is MP plus PT. So you see that? Alright. Now, here, we found PM. We found PM, right? Where is it? I think we found PM. Oh, it was in the rough work. We have to do it again because I erased the rough work. From PM. PM is 2/3 PL, but PL is negative R plus S. So let's say MP from M to P is 2/3 PL. So this is 2/3 PL plus, right? So we say from M to P is 2/3 the distance P to L plus PT. Now here we need to find PT. But remember now, PT is twice PQ. Alright? Because it says let's say again PQ equal QT. So P to Q is Q to T. So PT is 2 times PQ. So it's plus 2PQ. Alright? Now, 2/3 PL. We found PL already to be negative R plus S. So this part is 2/3 of negative R plus S. Remember, this is MT, the vector MT. Alright. Plus 2PQ. But look at PQ now. Notice, since all of this is a parallelogram, PQ has the same magnitude of OL and same direction. So PQ equal OL. Alright? So PQ is OL. You could say 2OL. Could write somewhere here that PQ is equal to OL. Alright? To show all the working. So 2OL you have here. Alright? Now what is OL? OL is S. So what you have, check on something, just make sure my battery, just make sure my laptop battery isn't running down too much. Alright, so here 2 times OL, yeah, but OL is S, right? So what you have is that MT, the vector MT, is equal to 2/3 of negative R plus S plus 2, remember 2OL would be 2S, would be 2S, alright? Now, the vector MT equal, let's open this bracket, this is negative 2/3 R plus 2/3 S plus 2S, alright? Now, we have negative 2/3 R, but let's deal with the S part here. Plus, now we have 2/3 S plus 2S. We're going to have to do some fractions here now. Want to use common denominators, so 2 means 2 over 1. If we multiply the 1 by 3, we get 3, but we must multiply the 2 by 3 as well. 2, 3 is 6. So 2 is the same as 6 over 3, right? 2/3 plus 6/3 is 8/3. Alright? So that's what you have there. So this is going to be 2/3 S, negative 2/3 R plus 8/3 S. Oh, how did I get a 2 alone? Oh yeah. So it's 2 of that. Alright, so you're following? Let's do a quick review and then continue. We already found OM from O to M. Now we're finding M to T. Alright? So MT is M to P plus PT. Now we know PL is negative R plus S. That's PL. Now, from M to P would be 2/3 P to L. Oh, I left off a minus sign, you know. Because if you're going from M to P, you're going in the opposite direction from PL, right? PM is really 2/3 PL. But MP is negative, so it's a negative in the opposite direction. So MP is really negative 2/3 PL, right? Plus 2 PQ, all right? And then, well, this would be a negative here. Let me move the equal sign in front here. Well, negative 2/3 of negative R plus S, right? That's PL was negative R plus S. PM would be 2/3 of negative R plus S. So MP would be negative 2/3 of negative R plus S. And then going from P to T is twice PQ. PQ is the same as OL. So it's twice OL, which is twice S. All right. There should be a negative here. Here. Alright, so if I open the bracket, this now would become a positive then. So negative 2/3 by negative R is positive 2/3 R. Negative 2/3 by negative S would be minus a negative 2/3 S then, right? Plus 2S. So negative 2/3 S plus 2S would be what? Well, alright, I'm going to have to erase this because I left off the negative accidentally. Alright, so let's rewrite this part. So MT is equal to, you're going to have 2/3 R minus 2/3 S plus 2S. Now we're going to have to do some fraction. 2 means 2 over 1. We multiply the 1 by 3. 3 ones 3. Multiply the 2 up top by 3. 3 2 6. So negative 2/3 plus 6/3, same as 6/3 minus 2/3, which would give you 4/3. So 2/3 R plus 4/3 S. Alright, suppose we factor out the 1/3 now. This is, oh, we could factor out 2/3. We factor out 2/3. And what we have is R plus 2 into 4, 2, 3, and 3, 1, 2S. Alright, so so we see that MT equals 2/3 R plus 2S. At the same time, OM is, what was OM again? 1/3 R plus 2S. OM equal 1/3 R plus 2S. Right. So you can see they are collinear, because this part here gives the direction, right? So you write that the magnitude of OM of MT is different from that of OM. However, the direction are the same. The direction of OM of MT, direction of MT is R plus 2S, and the direction of OM is R plus 2S. They have the same direction. It's just that the magnitudes are different. Magnitude of MT is 2/3, the magnitude of OM is 1/3. So the magnitude of MT is twice that of OM, but they have the same direction. So therefore they are collinear. You write it out plain and clearly. Alright? Alright. So you have that part now. Make sure you get it. Oh, let me see something. This is part A. Good. And then part B now. Matrices. Matrices. It says 3 matrices A, B, and C are such that A is 3, 2, 5, 4. B is 4, 0, 2. 3, negative 1, 7. And then C is 4, negative 1, 2, 7, 3, negative 5. Find the matrix AB plus C. Alright, so let's copy this. Let's just erase the board and put this down. Okay. Find the matrix AB plus C. Let us see. AB plus C. So AB, the AB part is going to be 3, 2, 5, 4 multiplied by 4, 0, 2, 3, negative 1, 7. What is that equal to? Now remember, it's row by column, right? So 3 times 4, first element in the first row times first element in the first column plus second element in this first row by second element in the first column. So here in the answer you get this in row 1, column 1. So you must multiply row 1 by column 1. Alright? First by first, that's 3 times 4 plus second by second, 2 by 3. So remember, 3 by 4 plus 2 by 3. Alright? Now, in the answer, it's still in row 1, but this is going to be in column 2. So you must now multiply row 1 by column 2. First by first plus second by second element. Alright? Going to be 3 times 0 plus, and so it's 3 times 0 plus 2 times negative 1. It's 2 times negative 1. Alright. You're going to have a third column. So it's now row 1 by column 3. Alright? So here now, first element by first element plus second element by second element. 3 by 2 plus 2 by 7. Alright? It's going to be 3 by 2 plus 2 by 7. Now we do the same thing here. This now, in the answer, what you write here is going to be in row 2, column 1. Alright? Remember, we have row 1 dealt with already, but this now is row 2, column 1 is going to be right here. Row 2, column 1. So it's going to be row 2 by column 1. First times first plus second by second. It's going to be 5 by 4 plus 4 by 3. So it's 5 by 4 plus 4 by 3. And then here, in the answer, what you put right here is going to be in row 2, column 2. Right? This is row 2, this is column 2. It's row 2, column 2. It's going to be row 2 by column 2. First by first plus second by second element. Going to be 5 by 0 plus 4 by negative 1. So you have 5 by 0 plus 4 by negative 1. Then this now that you write here is going to be in row 2, column 3. So you must multiply row 2 by column 3. Alright? It's going to be elements, first by first plus second by second. So it's 5 by 2 plus 4 by 7. So we have 5 by 2 plus 4 by 7. Alright, so we simplify these things now. 3 4 is 12 plus 2, 3, 6. 3 0 0 plus 2 negative 1. Well, it's going to be minus 2. 3 2 6 plus 2 7 14. 5 4 is 20 plus 4 3 is 12. 5 0 0 minus 4. And then 5 2 is 10 plus 4 7 is 28. Alright. So what you get is 12 and 6 going to be 18. 0 minus 2 is negative 2. 14 plus 6 is 20. I'm writing it too close. I don't want to write it that close. Let me give it some space. Now remember, this is just the AB part, you know. So AB equals 12 and 6 is 18. Then you have negative 2. 6 and 14 is 20. 20 plus 12 is 32. This is negative 4. 10 plus 28 is 38. That's AB. Then it says plus C. So AB plus C is going to be 18, negative 2, 20, 32, negative 4, 38, plus, where is the C? 4, negative 1, 2. That's 4, negative 1, 2. 7, 3, negative 5. 7, 3, negative 5. Alright. So you add the corresponding elements. 18 plus 4 is what? 22. Negative 2 minus 1, that's negative 3. 20 plus 2 is 22. 32 plus 7, that's 39. Negative 4 plus 3, that's negative 1. 38 minus 5 is 33. Alright, so that is AB plus C. Alright, 3 marks. They say find A inverse, the inverse of A. Let us see how that will go. Let me paste this. See where it went. Alright. Now, A is what? 3, 2, 5, 4. So A is 3, 2, 5, 4. Now, with a 2 by 2 matrix, remember, if you have A is in the form A, B, C, D, then A inverse is 1 over the determinant of A, which is AD minus BC, times interchange A and D, change the sign of B and C. Alright? Now, what's the determinant of A? Another way to write it is this. Or you could just write it like this. 3, 2, 5, 4. These are different ways to write determinant. BETA, or A with the vertical lines on each side, or the whole matrix with the vertical lines on each side, whichever way you want to write it. The determinant is 3 by 4 minus 2 by 5 equals 12 minus 10 equals 2. Alright? So that is the determinant of A. Now, the inverse of A is going to be 1 over the determinant, that's 1 over 2. Interchange A and D, so you have 4 up here and 3 down here. Change the sign of B and C, you have negative 2, negative 5, right? So what you really have is going to be, when you multiply a number by a matrix, you multiply each element in the matrix by that number. So it's half by 4, half by negative 2, half by negative 5, half by 3. So A inverse is equal to 4 over 2 is 2, half by negative 2 is negative 1. This is going to be negative 5 over 2 and 3 over 2. Alright? So, that's what you have there. Now, let me see something here. That's A inverse. Then they say write down the 2 by 2 matrix that represents the matrix product A inverse. So let's paste this here. Let's drag it down. Alright. Now the thing is, when you multiply a matrix by its inverse, what you get is the unit matrix. In this case, it's 1, 0, 0, 1. Alright? And we could also test it out, you know. A is 3, 2, 5, 4. So you have 3, 2, 5, 4. In exam, you wouldn't really have the time to be testing it, but we're not in exam today. 2, negative 1, we run out of scrolling space, you know. 2, negative 1, negative 5 over 2, 3 over 2. Negative 5 over 2, 3 over 2. If you multiply these, you get 3 by 2, which is 6, plus 2 by negative 5 over 2. The 2 would cancel, so you have negative 5, alright? 3 by negative 1, that's negative 3. 2 by, alright, let's just write out everything instead of taking shortcut. 3 by 2 plus 2 times negative 5 over 2 will come here, right? 3 by negative 1 plus 2 by 3 over 2. You have 5 by 2 plus 4 by negative 5 over 2, and then 5 by negative 1 plus 4 by 3 over 2. What is this now? 326 minus 2 cancels 2, you have 5. This is 3 by negative 1, negative 3 plus 2 will cancel 2, leaving 3. You have 5 2's 10. Then this would be plus negative, so it's minus 2 into 2, 1, 2 into 4, 2, 2, 5, 10. And 5 by negative 1 is negative 5 plus. And then you have 2 into 2, 1, 2 into 4, 2, 2, 3, 6. So you will get 1, 0. 10 minus 10 is 0. Negative 5 plus 6, 1. Right. So you get the unit matrix there from testing it. Alright. So that's it for question 10. So, end of test. If you finish before time is called, check your work on this test. Alright, nice, nice, nice. So, that is it. I wish you all the best in your next exam. The exam that you're preparing for. Alright?